Good evening. Great turnout tonight. My name is Rachel Manhalter, and I would like to welcome you on behalf of South Dakota School of Mines and Technology, South Dakota Public Broadcasting, and Haycamp Brewing Company. This, for any of the new people in the audience that have not been to Steam Cafe before, this is a monthly program that we put on. Our hope is that through this, you can come and learn about the cool things that are happening right here in Rapid City at School of Mines, and also possibly build new relationships and even your own collaborations. So that's really our hope for this. So come on back next month. It's going to be a really great talk. I'll talk more about that at the end of this session. Tonight's talk is really fun. I have been talking to some different faculty and staff on campus as I was preparing for this month. And when I would hear mention of John and Phil Hillard, they were compared to the Wright brothers. You'd see the faculty's eyes just light up and so excited to tell me how cool their research and their work is. So I'm just excited for all of you to learn more about what they're doing. Our speakers are John and Phil Hillard. They are brothers, and they are both in our mechanical engineering program. And what they have been doing is taking their passion, which they'll share more about it with you, and turning it into just a great opportunity to supplement with education and hopefully build a niche in the aviation industry in the future, or in the present maybe even. So why don't you go ahead and join me in welcoming them to the stage.
How's it going, everybody? I don't know how close to hold this. There you go. Yeah. Thanks for coming. This is awesome. Thanks Haycamp for throwing it, and like Mines for supporting us. This is great. So, yeah, I'm John Hillard, and this is my. Yeah.
I'm Phil Hillard. We're really excited to show you a little bit about what we've been working on the last couple of years, and yeah, let's take it away. This is a really cool paramotor presentation. So, a little bit of. Oh, okay. There we go. Can you hear me a little better? Okay, there we go. So, a little bit of our history. We come from a family of pilots. Our grandfather was in the Marines. He flew C-130s and helicopters. Next slide. Our dad is a naval pilot. He flew some of the biggest helicopters in the world, and he always kind of instilled a love of flying into us from a really young age. So as you can see, this is one of my birthday presents. It's when I was just a little guy, just putting together some cardstock gliders. And this is John in the purple. I'm whispering little aviation secrets to him from an early age, trying to get him started young. So, and these are some more recent photos. John and I both together we purchased a share in a Cherokee 140 airplane. We've been flying for a little while now. I got my pilot's license in 2012, and John's currently working on his license. And so we've really been into aviation for a long time. We've had a lot of fun. We've taken the plane all around the hills, explored a lot of airports, and kind of just had the time of our lives in the Cherokee.
This is you.
Okay, so this first little video is when we first started to get into the sport of paragliding. And this is some of our first equipment. This is on the top of M Hill, and this is our first flying experience in Rapid City, actually on a paraglider. And we thought, let's start with M Hill. That sounds like a good plan. So if we get hurt, at least there's people around that can take us to the hospital. They'll see it. So it's hard to see. You can't really see in the video. But a funny story is our parents were in the drive-thru at the Walgreens, and Dad says to Mom, "Hey, look, somebody's flying up." "Oh my gosh, that's Phil." And so they drive up, kind of behind Fisher Furniture. There's some dirt mounds, and Dad climbs on the dirt mound, and Mom says, "Is he going to be okay?" And Dad says, "Shh, don't distract him." So as you see, the landing went well. So this was really fun. I got John into the sport a couple years later too, and John actually ended up making the same flight.
Yeah, so how many years later? Let's see. That was 6. Yeah, so 5 or 6 years ago, I did the same flight. It was a blast. Let's see if it'll work. Whoop, I point it there. There you go. So you inflate, you pull the wing up above you, or behind you, and then it comes like, whoop, up above you. And then you like a lot of people think the sport is like jumping off a cliff, but it's like a really nice kind of run until you get light and then you fly away. My wife's down there, right there. I think I'll wave to her in a second. Ah. Oh man, with a pretty good wind, I bet you could ridge soar there for a little while if you stayed in it. Yeah. Almost hit the fence. It's like, yeah.
And you made it.
Yeah. Love you. Thanks for letting me fly. Let's see here. Yeah, here you go.
So the natural progression for us for this sport was we started running out of hills and we wanted more flight time. So the next thing that we started looking into was sport of paramotoring. So when you start with paragliding, you add the motor, it becomes paramotoring. So, oh, hi Uncle Fred. Didn't see that. How's it going? Basically the equipment of the sport, as you can see, you've got your wing that provides the lift. And on the right side, you can see the engine. It's just a standard two-stroke engine. This one has a belt reduction drive that spins a propeller. On my right hand, you can see a throttle and a little gas tank. This is some of our first equipment. This is our first paramotor unit. So. Okay, so this next video gives you kind of an idea of what the sport looks like. From the perspective of the pilot. So you launch the wing and you've got your motor started and full throttle, run, and away you go. So it really is an amazing sport. It's a lot of fun. You get amazing views. As far as regulations go, you don't need a license. It falls under Part 103. It's the ultralight category, so your aircraft is under 254 pounds. And, you got to check your texts. You always have to check your texts. It's very important. This is fun, kind of flying over the cell phone tower there and landing back to the field. So I actually went over to my folks' house and I called them. What I was doing is I was calling them, and it turns out they weren't home. So that was a little bit of a bummer.
Sure. Okay, so paramotors are awesome, just as they are, but there's definitely some problems with internal combustion. So they're two strokes, so they're oily, they're messy. You gotta pre-mix oil into your gas, and you can't like put it in your house because it smells like a lawnmower covered in gas. And they're really loud, like really loud. They're also heavy. So I saw Phil, Phil was definitely the first guy to fly the paramotor, and it was just too heavy for me. And so we started thinking like, okay, we already build RC airplanes, we build drones and stuff. So we're the gears are turning on how to make it easier, So it was, that was our goal. Make flying easier to do. Just plain and simple. I want to go flying, And so, the fix was go electric. Electric's awesome. So, the benefits of going electric, they're dead simple. Like, for real. There's like two moving parts on the thing, which is nice for, compared to a two-stroke. You've got all sorts of stuff going on. They're way quiet, and so when you're actually up there, it's a lot more peaceful. It's like a true flying experience, like you're a bird, which is pretty fun. They're also way compact and lightweight. I can put the wing and the whole paramotor when you pop the cage off in the back seat of like a Mini Cooper. So as an aircraft, it's pretty good. Mini Cooper? Yeah. Hey, there you go. I miss mine. Yeah. Yeah, for sure.
So like John was saying, what you don't see is a lot of time that we spend in the field fiddling with carburetors, cleaning off fouled spark plugs, airing out flooded engines. So we've spent almost as much time flying as we spent just trying to get our two-stroke engines to work. And when they're finally tuned in, they work fine. But you've got a lot of there's a lot to know to be able to get in this sport. There's a high learning curve. So I really wanted to break that down and kind of take it into the realm of the standard consumer, where you can have just a single button, turn on your unit, and you've got power on demand. You just go flying right then and there. So that was part of the inspiration for this project, was really just simplifying this whole sport. So this is what we're looking at is the version 1 of our paramotor, the very first version that we started. You can see on the bottom we've got some lithium polymer batteries. Should I tell them the story about the batteries from China, the label? Okay, so we've got a kind of a funny story about the batteries. So there's a limit on the capacity of the cells that you can ship overseas. So, John and I, we searched for the biggest batteries that we could find, highest capacity, and so we made the order, and we got them in the mail, and we opened up the box, and the capacity was labeled on them was about 1/10 of what we'd ordered. And we had this moment, we're like, oh no, oh, what did we do? We found the wrong people. They took our money. Well, it turns out that China just puts a different label on them because you can't send, these are higher capacity than is legal to send overseas. The funny part is they sent the actual labels in the box with them too. So we just took the actual labels, put them over the over the fake labels, and that's how China gets around the battery laws. So. Okay, so this video kind of shows some of the development of that first version. Can we maybe turn that volume up a little bit? Very first time we ever spun the motor. It was a big moment. This is all engineering grade insulation too, if you can see. Safeway bags.
Yeah, we fixed that. So yeah, the propeller hit the cage.
So this is one of our first thrust tests with instrumentation. Dr. Dolan was able to help us out with that. As you can see, we had a little bit of fireworks going on there. So the lesson that we learned here is that grounding out the frame is not a great idea. But we did make the world's first electric paramotor welder. Unfortunately, that day we were able to get the problem fixed and continue the test. It was a successful test that day. And here's the welded bolt. After a little bit of insulation, we had a little bit more success. We're measuring power, thrust, and amperage, and decibels, noise, and temperature. 110 pounds of thrust. So that was a really great day.
Yeah, I love Elon Musk. I'm actually wearing a SpaceX shirt right now. I don't know, they blow stuff up and they fix it and they make it better, and they really push the limits. I think that's so awesome. So I love this quote. You want to be extra rigorous about making the best possible thing you can. Find everything that's wrong with it and fix it. Seek negative feedback, particularly from friends. I love that. So we definitely learned from version 1. It totally made a lightning tornado. And so, yeah, we revised it. And this is really the cool thing about being an engineering student or an engineer in 2018 is that you can turn around iterations so quick. So we do what's called iterative design. So that's where you do as much math, as much engineering, as much analysis as you can, and then you build it. And then you test it, and you break it, and you make it better. And so that's kind of what we've been doing the whole time, test, revise. And so, yeah, we learned some serious lessons from that one. It was our first time venturing into really high power systems. So it was basically a scaled up version of what we know how to build, like a drone. Yeah, so battery safety, first priority for sure, is a lot of energy. So we spent a lot of time making sure on the next one that was going to be good. It's heavy and bulky. We went big on our first one, and so we decided to kind of pull it back a little bit into something that you see that size, a little bit smaller, lighter, a little bit more simple. And we needed instrumentation. And so on the next one, we needed a smarter battery. Like if you fly like a new drone, a DJI Phantom or a Mavic or something like that, you don't even have to think about the battery. It monitors itself. It'll turn itself off before it hurts itself. It'll monitor its own temperature. It's all stuff that we wanted on the next version, so we put a lot of time into that. 70 emails with a battery manufacturer in like 6 months to get the right one going. Wow. It was a long time. Real-time monitoring, redundant fail-safes. Like we wanted this thing to, like one component would fail, but another one would detect it before that happened, and definitely that was the direction we wanted to head. And again, lighter weight, longer flight duration, just more performance. We decided to build version 2. So this is a SolidWorks model of it. So we're using 224 lithium ion cells. So we stepped away from lithium polymer, and we moved into the same kind of cell that's used in the Tesla Model S. It's a 18650 made by Sony. And then instead of just plugging in the battery, now we moved to a contactor. So that got rid of a lot of the lightning when you plug it in every time. And then we also have a battery management system. So that's that green. We were just getting dimensions from the battery manufacturer to make sure it fit. So that's kind of why it's simplified. But that is the brain for the whole thing, for the whole battery. So it monitors every cell. It makes sure that they're all happy. And if one side's, getting pulled more, than the other side, it'll kind of equalize it and make sure all the cells are happy, which is critical. Batteries can be really safe as long as you treat them well. It's like when you don't treat them well, that's when you start running into like phones exploding and stuff. So we got our new stuff in. Took months. So we went to just like one motor with no belt reduction, so it was way simpler. Instead of having a motor and then a gear and then a belt and then another gear and bearings, we just simplified the whole thing. And then that's the charger, the black box. And so the cool thing about having a computer running your battery is that you don't have to really do any thinking when you charge it. You just plug it in. It takes care of everything for you, which is a huge step in the right direction, I think, for charging it. So, so this is kind of cool. I was sitting in physics one time. I think it's physics 2. And I had this idea about the throttle. And I go to Mines, so I have access to a lot of stuff. And so on my lunch break, I hopped on SolidWorks, sketched it up, and then went to the mechanical engineering building, went to a computer, 3D printed it. By the end of the day, like from the beginning of the day, I had the idea, and by the end of the day, I had a working throttle for the paramotor, which is like pretty cool. It's like super future-y. 3D printing is awesome. Yeah. You wanna talk about the welding here?
So this is kind of we've got some images from when we were building the frame for V2. We had learned a lot from V1, and we knew that we wanted to cut a lot of weight. We had accidentally gone too bulky, and we overshot our weight goals by a lot. And so we really went light on V2, and you can see here we've got a lot less material, thinner walled aluminum. We've got a double hoop that's just pretty standard in paramotors. It gives you a lot of strength. We've got our motor mount here. These were the mounts from the original batteries of the lithium polymer cells that we had by this point we'd upgraded them. This is you can see we're kind of playing with netting ideas. The whole idea with the net is, to keep your limbs out of the prop. So if you do take a spill on landing or on takeoff, you want to avoid that prop definitely. So this is almost a complete final version of V2. We've got, as you can see, we've got a little bit smaller unit. It's definitely a lot lighter. Turned out to be about 40 pounds. And we've got our netting installed, we've got it painted, and it's just almost ready for its maiden voyage.
Okay, so the whole thing weighs 40 pounds. So the battery's the majority of the weight. If you look at really any electric vehicle, that's really the thing that they're trying to improve is the weight of the batteries. And so, yeah, that's 75% battery by weight, but it makes 80 pounds of thrust. So it's not a powerhouse in terms of industry paramotors. When you're dealing with a two-stroke, you can get a lot of power, but it's totally enough to fly. So you can fly for about half an hour. It's got 5 layers of redundancy for fail safes. So if something fails, you can fail. You can have stuff getting too hot, and it'll detect it ahead of time, make sure it protects itself, which is important when you're in the air. You can't just get out of your car. You have to land. So.
And to touch on that, one really great piece of advice that Dr. Dolan gave us was he said that in order to approach safety, you should start from the worst case scenario and work backwards. And we thought, okay, well, what's the worst thing that could happen? Is, a big flaming lithium polymer battery fire 1,000 feet above the ground. That would be really, really bad. So we started choosing components with systems that could give us that redundant safety. So.
And we wanted one button operation, so we didn't want to choke, we didn't want an idle adjustment, all that stuff. We just wanted one button. You turn this thing on, and it's like a big red switch to make sure if something goes wrong, you can find it and hit it and turn it off. So that was really our priority. Let's see here. Oh, this is the first time we spun it up. This is right outside the mechanical engineering building. We fixed it. It was a wire popped out. It's kind of serious time. We're like, oh, is it going to work? The throttle response with an electric motor is awesome. Yeah, so we tested it, and we would strap it to a bench and test it, and then we decided to fly it, and we had one successful flight, made some tweaks, and just kind of as a rule, my brother and I don't, ever since way back in the day when we were flying RC airplanes and stuff, we wouldn't invite anyone to come to our test flights. That's because you never know what's going to happen, and so you just don't invite anybody. Yeah. like literally for years. And so we're like, okay, let's go. We're going to do another test flight. Let's go to Custer. It's like, the only people that are going to see us is buffaloes. And so we go to the Custer State Park airport, and there's a news crew, which was awesome. It turned out to be great because it worked. But yeah, we were not planning on that. So they actually did a news story on us on our second flight ever, right? With the electric one. Yeah. So here it is. Yeah, it was great. They did an awesome job.
Electric cars promise to make vehicles more reliable and cheaper to operate. Now, 2 engineering students at the School of Mines want to help extend those advantages to the world of flight. As Hillard's Alvance shows you, the 2 are researching the use of electric motors in aircraft.
Aviation used to be the exclusive world of fuel-burning engines. It still is for the most part, but these 2 brothers see a better way to do it, and they're taking practical scientific steps to make it happen. Phillip and John Hillard are mechanical engineering students at the School of Mines. They want to help explore all the applications of electric motors for flight.
We are really designing this from an approach we want to make it as user-friendly as we can. So kind of open up a new market of pilots.
The Hillards are starting relatively small. They've designed a 40-pound backpack that contains a battery with enough power for a 5 to 10-minute flight. It includes a lightweight electric motor bolted to a propeller with an adjustable pitch. The backpack is connected by lines to a conventional paraglider wing. The main focus of the testing is on the motor, propeller, and battery.
It's a beautiful time where batteries are affordable enough and high performance enough to be able to kind of start integrating with existing sports.
John Hillard is the test pilot for this flight at Custer State Park. Once he starts his ground run, he turns on the motor and begins to rise almost immediately.
It solves a lot of problems. So really where you gain the most, I think, is in simplicity, weight. It's quieter. You've got awful power on demand.
An electric motor has more torque and low RPM, so bringing in power can help a pilot get out of a tight spot more quickly, making the machine safer. Both brothers are convinced that because electric motors are simpler, they only have one moving part, they'll also be more reliable, which will also add to the margin of safety.
We can get the thrust that we want, we can get the weight that we want.
As John rises above the airport, he and his brother can already see those features of their new machine being demonstrated. And beyond the engineering aspects, the quieter, safer, and more reliable operation adds to the already exhilarating experience of flight. In Custer State Park, Hillards News.
So we were really fortunate to have a successful maiden flight of version 2. Thank you. It went really well. Everything performed like it should. So thanks very much. Funny story. We showed up, and Al Van Z is in a Cherokee with another guy doing a story with him, and we showed up, and he said, hey, do you guys mind if we're going to maiden, we've got an electric paramotor that we're going to fly here, and they said, no, we don't mind at all. And so I said, maybe I'll do a story on you, and I said, we were like, oh boy, okay. So we said, okay, that's fine, we can do this. And so we get back to the van, and we realized that we had left the propeller back in the lab in Rapid City. So it was an hour drive back, and an hour drive back to Custer, and we told Al, we'll be back, we promise, we're not scared, we're going to do it, we're going to get the prop. But we're really fortunate that everything turned out really well that day. It was a stroke of luck to have the news there. So, but yeah, so anyway, to touch on goals for the future, we'd like to secure funding because we'd like to continue development on this paramotor. We'd like to take this sport, open it up for more people, kind of break down the barriers to entry, make it a lot more simple. Electric takes a lot of the traditional headaches out of engines and does away with them. And I think that safety is a big factor too. I mean, we've seen instances where, with a traditional gas paramotor, you've got a tank that has 3 gallons of fuel with a spinning prop inches from it, and any impact can take the prop into the tank, and suddenly you're covered in fuel, and that's never a good thing. So really, we think we've taken the sport and we've really increased the safety quite a bit with this electric unit. So, yep.
Guess I just want to open it up to questions and answers, I guess. Yeah, Chuck.
Didn't you have some problems with selecting the correct prop?
Yes, we did. Definitely. On the first one, we worked with a company in Germany for a couple months to get that one right. This prop was cool because this motor and this prop are actually designed together by a company called T-Motor, and they're actually designed for a crop spraying drone, and so for like agricultural drones. And so you get a big, tank of pesticides or herbicides or whatever, and then you don't have to have a crop dusting pilot come over. You can just fly it over your land. And so there's these really awesome, just like super high quality, powerful parts coming out for that industry. And so instead of using 8 for a big drone, we just used 1. So the prop, luckily the heavy pulling as far as math goes was done for us. But